Okay, so here we are with the first worked example, which is going to be this snow effect. If you don't see it and you've been following along and you used a very high wind intensity to see the wind blowing on the previous example, that's what's affecting this. Set that back to 1. The wind intensity has been used in 2 different places in 2 different scales, which is obviously a terrible idea, but there we go. We'll use it here. We'll use it as a 1 as a sort of standard, and not use that very high value that we saw before. So that be, if you don't have these particles here, just double check your wind intensity here in the NPC, because it's obviously reading the same value. Okay, so we'll open up what we have here and we'll just do a quick overview of what's been made and look at some of the notes, and then we'll make it ourselves completely from scratch, and kind of replicate this entirely. So there's definitely a few new things in here that we haven't covered so far. So starting with the hanging particulates template, let's do this as an overview and then go back and actually make it. So we'll start with one of the templates from the engine. They're pretty good starting points. They have a lot of information and things with them, and so we're going to use that. It's going to be very useful. We have NPC parameters for wind spawning and shape. So when placing this in the world, we have access to how big a volume do we want, how many particles do we want. We can scale this right down, 0.1, 0.05, 0.01, tiny amount of particles now. Can't even see them if they're not really selected. At least you can. There you are. And obviously we can go the other way as well. So let's do 5, 50. Way too many to even read it as snow, and also cause performance issues. So let's not go too high. But we have a wind scale value here. So this is what I was saying before about having it not only controlled by the NPC, so you can control it globally for everything in the world, but also controlled by the user parameter on the object, so it can be kind of overridden here. So if we wanted to place one of these maybe in a little kind of valley that didn't have any wind, well, if we can set it to 0, we'll now have no wind scale. Still a little bit of noise happening there, but interesting. Random sizes and forces, so random location, random size, randomizing as much as you can to create some variation. Simple 4:9 sprite sheets. In this case, we're using a 4 image sprite sheet. So this is like a flipbook, same idea of it being broken down, but instead of being an animation, it's just you pick one or the other. So I call an animated one a flipbook and an unanimated one a sprite sheet. But effectively it's just a texture with multiple images on. Yeah, we're using aerodynamic drag. I'm also using this new module that I don't think we've covered elsewhere. Avoid distance field surfaces GPU. So if we're using the GPU emitter, which we are, it knows where the distance field is, and it can do this kind of avoidance. And so it's a new script, it's a bit experimental, but basically it allows us to sort of get particles to, instead of just pushing through geometry, they know where the geometry is and they can kind of avoid it a little bit, which is quite nice. We're doing scaling particle size by distance. So we have a scratch module in here using the collision query, camera query. We're just getting the distance from the camera to the particle, and we can use that to create effectively a scale. So one of the problems with little particles, let's not do that on a screen you can't see, but one of the problems with little particles is as you get towards them, they get big on the screen and then they don't look good anymore. So if we scale the size of our particles by that distance, we can kind of alleviate that problem, and we'll see that as we build our effect. We're also doing a scaling wind speeds by normalized world height. So this is a nice little trick. If we're building a large world, we don't want to have to place an object and then scale it and place it and set the settings, place it and set the settings. We can do that. It's going to take some time. If we're doing a lot of these, it's going to be potentially quite expensive or quite time consuming. If this is attached to the player, well, we don't want to have to kind of like keep changing values depending on where you are in the world. So instead I've made this sort of logical connection. Basically, the higher you are in the world, the more wind is going to be. As you're climbing up a mountain, it gets windier at the top. And And so if I take this and just duplicate and scale it up, if I move up here, well, actually, I think it's set to be quite small scale, but if I move it down here down to 0, the wind speed is very slow. As I move it up, the wind speed picks up. And so by building in that kind of dynamic element, we're able to kind of add a nice element of dynamism to our effect. It doesn't have the same values everywhere in the world. So as it's attached to the player, we have very low wind speeds, very subtle snow moving around, and then very high wind speeds. And obviously we could do that for things like spawn rate, scale, anything we want. Again, this idea of just having, once we have data, we can use that data to drive anything. Couple of other things, or last bit in here, output in depth and velocity. If we open up this material, one of the absolute worst nightmares when dealing with tiny particles is that you get TAA smearing. So little particles, as they spawn and move through the world, the previous frame, that's in the previous frame, that's visibility in the previous frame, and then the temporal anti-aliasing kind of blends the frames together and you get horrible smearing. But there is an option for output depth and velocity. If we disable that and just apply, we should see much worse visibility here. And that's happening because of the TAA smearing. So the little particles are being kind of like rendered over multiple frames, but then you get this little trail. It really doesn't work very well. If we enable output velocity and depth, now the TAA system knows which way the particle is moving and it can kind of compensate for that smearing, which is quite nice. Okay. One note with that, if we are using the output depth and velocity, you can't use depth fade anymore because the depth fade also requires depth. And so because we're writing to depth, we can't also read from depth. Although I think you can use scene texture. Someone mentioned this the other day. If I use a scene texture depth, scene depth. So it might be we can build our own depth fade based off scene depth, because that doesn't give you the same error. Pixel depth, that will be okay. Yeah, okay. So it might be we can fix that. So we'll have a go at that potentially as well. Oh, do need opacity though. Okay. Okay. Right. We're also going to make our own dynamic input. And so we have a dynamic input in wind force. If I have a look at wind force, just simple dynamic input. Everything that we've been using, any of the values here, these are called dynamic inputs. We can make our own. Now, really, a lot of them are very simple, very mathematical. There's no need to replicate those, but if we want to do something custom, we can. Never use them very much, but one thing that comes up quite often is we want to multiply lots of values together at once. And you can just nest multiplies, multiply into multiply, etc. Which is fine, but it's much nicer, I think, to have a multiply many. So in this case, there's 4 inputs and they're just multiplied together, and we'll have a look at making our own dynamic input for that. Okay, that's everything that's going to go into this as an overview. We'll get started in the next video actually making everything, doing it all from scratch, and building up our snow effect. Okay, so let's start with a new Niagara system. A new system from selected emitters, and we're going to start with the hanging particulates template. Done, and I'm going to call it my snow, or maybe class snow, that's what I normally use, class snow. And we'll just take the effect here and swap in R1. Okay, let's bring that into view. So, first thing we have is our particles hanging in the world. I'm going to rename this straight away to something that makes more sense. And now we have a few choices. with particles, you kind of need to do a little bit of everything before you can see anything. Now we have started with a template, so we're seeing stuff here, but we want to kind of go through and think about shape. Well, think about this, what we saw earlier, I suppose. Think about spawn, think about location, think about forces, and think about rendering. So those four things. You need to do a pass on all of them before you can really see how any of them are working, and then you go back and do another pass and go back and do another pass, and so on and so forth. So let's do them in the order that we did before. So we'll start up at properties. First thing I want to do is change this to a GPU sim, and I'm going to do a fixed bounds, and we'll leave it at 100 for now. We might see some errors with popping. If we move the camera too far away from the origin, things will disappear. I think they do there kind of at the side, yep. But we'll kind of need to do that at the end and do that as a final thing. Yeah, fine. Could turn on local space. Depends on what we're using this for. If it's attached to a player, it doesn't want to be local space. If it's placed in the world, it probably makes sense to be, because it never moves. It doesn't matter if it's local or not local, and so having it local makes it easier to place. But we'll assume this might be attached, so we'll leave it out of local space for now. First thing then, coming down the list, our emitter state, here it's set to self. Well, actually, there's an additional cost to that. We can just have this set to system. And so it's taking the system state here, so we're having a 5-second infinite loop, which is great, nothing wrong with that. I'm going to have a spawn rate. Now our spawn rate, in this case, I want to have a user control for it. And in actual fact, I've created an NPC control as well. So I've created a sort of global spawn value. Not that useful, but could be, well, it's something I like to sort of think ahead. When you're at the end of a project, you're thinking about optimization, thinking about having kind of like controls to tweak the look of things. Having a global value that can control the spawn scale of all your particles is quite a nice control to have. You can do something like an optimization thing. So on high-end systems, you can have like 1.5 times the number of particles, and low-end systems, you can scale the number of particles down. It's very heavy-handed, but it's also very, very quick. And so there are pros and cons to that. And also just kind of like, as you're tweaking, you can say, right, I want a few more, a few less. The important thing with that is if you put it in at the start, then when at the end, it's useful to have. If you don't put it in the start, you're never going to do it, because it's a real nightmare to go through effect by effect and add it back in again. So just a little bit of forward thinking. And so because of that, we're going to do a multiply many in here. And we're going to multiply a spawn rate value. So how many particles do I actually want? A NPC particle spawn multiplier. And this is my, let's say, my NPC value, which defaults to 1, but can be controlled through the Niagara parameter collection. And then finally, a user parameter. And I'm going to call this not C spawn rate, but just spawn rate. So now I have a inbuilt value, which my VFX artist is going to edit until it looks right. I have an NPC value, which can be edited on a global scale, which can be controlled by gameplay code or for whatever reasons later on, and it'll affect everything. And then I have my user spawn rate, which can be controlled on a sort of per instance basis. Should be seeing particles. I am not. Why am I not seeing particles? This just double check that the NPC value is correct. I don't think showing content browser, is that going to work? No, that finds the interface instead. NPC global parameters. Particle spawn multiplier should be set to 1. Why is that not working? Let me just undo this a second, see what happens. What's gone wrong here? Yeah, this is fine. Is it because I renamed my user parameter? That's almost certainly what the problem is. Let's try that again. Multiply many. We're going to do a local value, NPC, not wind intensity, NPC multiplier, and then user spawn rate. 50. So I promoted this to a parameter and then immediately renamed it and broke the link. well, let's fix that. There we are. Because we're multiplying, the fact that this is set to 1 doesn't actually make any difference to anything. We just get a control to that. Cool. Actually, what we might do for the last one, I might do a curve, float from curve. We're going to use the emitter looped age. So remember, this is a 5-second loop. Maybe we'll recalculate our duration each loop and make our loop a random value between, let's say, 3 and 5. So sometimes it's a 3-second loop, sometimes it's a 5-second loop. And what that changes is this spawn rate. And so sometimes it's going to be spawning lots of particles, sometimes fewer, and sometimes it's going to go all the way to none. And we can animate this or change this animation curve as well. So maybe we'll do something like this. We don't ever want none, but we can animate our spawn rate so we get slightly more, slightly less. Something like that probably works quite nicely. So just building up our level of randomness. I'm going to try not to do too much tweaking. It's very easy to fiddle. As I say, you kind of need to do a bit of everything before you see anything. But this is quite a nice way of working now. So I have, like I say, a local control. I can just edit within my module, no problem. A global control that can be edited everywhere. A user parameter to control it in the object. And then an animation that's controlling things over time or breaking up animation over time. Cool. Let's crack on. I'll try and make these videos a little longer because there's a lot to get through. Initialize particle. Now, lifetime of a particle is probably a bit high. Bring that down slightly. We'll leave it pure white. Size-wise, yeah, 1.5 to maybe 3 is probably good enough. Rotation, well, we're not seeing anything here because it's a purely circle, but having random rotation is going to be good because we're going to put some texture on this eventually. And random X and Y, we can randomly flip our UVs. So that's all pretty good defaults that we got from our template. Shape location. Now, I would take this. We probably do want to use box, not a problem, but I'm going to take box size and just promote that to a user parameter. And that just means that we can then go in and scale the size of our emitter. Now, that does mean we can make our emitter bigger than our bounds. Maybe we can go in and do programmable. It needs to be set from outside. So there is a problem here. I don't think we can do anything when we change the inputs of our bounds. Well, if and when that comes up as a problem in your game, you'll maybe have to just go in and fix it. It's one of the limitations of GPU emitters. You do need to have the fixed bound set correctly. So if I went in my box size, I put that over a certain value, it's going to cause problems. We could do a clamp potentially. That might be worth doing. You could go in and do a check on this to make sure it wasn't bigger than the values you put in here. And then that also causes problems because the user's putting values in and nothing's happening and they don't know why. So a slight problem there in sort of the way the UIs and things interact. If we could change the inputs here to be dynamic, we could do that, but unfortunately I don't think we can. And it doesn't give us an option in the input as a drop down. But we do have the user parameter now for box size. That's fine. We can make this box bigger and smaller. We can control the spawn rate as well. That's the end of the initial parts. Now we'll have a look at the update and what's happening to the particles during their lifetime, and we'll do that in the next video. Okay, so working through the modules that we have here already, and then we'll add a few more. So particle state, kill 1.5 times expired, that's fine. Wind force, this is where we're going to have that connection to the material parameter collection, sorry, Niagara parameter collection. So for the wind speed, I would do float by vector. For the vector, it's vector from linear color, and the linear color is NPC wind direction, so a global parameter. We also have a NPC wind intensity, so again, another global parameter that can be edited. And then for the wind speed scale here, let's do another multiply, and we'll do a user parameter. I'm going to rename this again. Rename wind speed scale, and that should just pick it up automatically. But I'm just going to reconnect that. Maybe the promoting. Here we go. Didn't work before. So wind speed scale. And now in the last input, we're going to do a random value as well. So just to create a little bit of variation as well. So lots of data all doing different things for our wind speed. The wind direction is a global. Wind intensity, again, is a global. So if you have a different levels, you could have a controller. If you have different kind of changing of seasons or changing of weather, that kind of stuff, you can do it through a global parameter. We have a user override, and we have some inbuilt randomness as well. Cool. Now for our intensity, we kind of have to decide, is this intensity going to be 0 to 1? If so, we need a bigger value within here. And let's say this might be something between like 50 and 150. And now we're seeing that wind really having an effect. Or do we want our wind intensity to be from 0 to many, and this to be a scale factor, and this could be then 0.5 to 1.5. So this is what I didn't get consistent between the snow here example and the previous example. But I think the best way to work is going to be wind intensity as a 0 to 1 value as a multiplier, and within the emitter itself, I'm going to do my bigger numbers there. Hopefully that makes sense. Doesn't matter which number is bigger, but one of them wants to be, but it wants to be consistent throughout the different systems. And I think keeping this as a global, as a normalized value, and the bigger values here makes more sense. Okay, aerodynamic drag. This is probably pretty good, just as some defaults. No problem with that. Scale sprite size, well, they're going to spawn in, scale up, and then scale down again. That's, again, also fine. We can make some tweaks to this depending on the look of our particles. Same with scale color, fading in and out. All these defaults pretty well put together for us. And that would work. Looks kind of like snow, but we've reached our renderer. We want to have that material. So if I write in snow sprite sheet, this is a 2x2. We know what that does. We know how that works. We can do sub UV 2x2. Now, at the moment, we're only ever playing or only ever seeing the first of the 4 frames because we've got no sub UV animation in here. So if I go into particle spawn, remember in this case, we're just randomly selecting between the 4. We're not animating. So in spawn, we can do a sub UV animation. Doesn't make sense to be called animation if it's in sub UV spawn, but there we are. And we want to set this to random and just tell it to refer to the sprite renderer. And now we have 4 different frames. They are all pretty similar. Snow looks pretty similar, but that gives us a little bit of extra variation. I might just up my spawn rate to make a bit more visibility. Maybe not as high as that. Something like 1,000 maybe. Okay. Wind force already has curl noise in it, but we might want to add some more. Let's do a curl noise like so. We can do this as a very kind of low frequency noise and maybe quite a high strength. Again, not going to sit here and tweak with values until it all kind of works exactly how we want. Depending on the reference that you're looking at, and always be looking at reference. Obviously, we want to plug in values that kind of replicate that and match. With the noise field, we can pan our noise field. Now, it might be that we want to pan our noise field in a very specific direction. So we can make this a user parameter, but what I quite like to do is just do linear vector from linear color and actually use the wind direction. And so the noise field is moving along the wind direction for our curl noise. It just means that as the wind changes, you'll get your noise changes as well, which I think works quite nicely. Cool. All right. What other modules did we have in here? Void distance field surfaces GPU. That's in update. Can't spell. Avoid distance field services GPU. Now the values we need for this, the defaults are a little bit low. If we look at the world, and I might have to just go in and give it some wind. So in our wind direction, we're going to set this to -1. I'm just going to up the intensity so it blows into the wall a little. Something like that. Yeah, the avoidance values are maybe a little low. It's not too bad. Obviously some things are going to go through. It's not perfect. It's not a completely hard cap, but we are getting some avoidance here. And so I might just up these to slightly higher values, but like, as always, your numbers might vary. And there we are. We're getting kind of the snow hitting and slowing down as it's hitting the wall, which is quite nice. Oh, let's not do that. Okay. Just checking my notes. What else have we got in here? Size and scale, all this stuff. Curl noise, yeah, that's great. Size, scale, things. Okay, that's all the sort of more basic setup stuff. Last thing we're going to do is some of the more dynamic input things. So I'm going to do a camera check. These are a bit too fast moving for now to see it, but occasionally we get a particle completely in the camera, and although it's kind of a texture, a very small thing, we don't really want to see it as a small thing in front of the camera. It doesn't look very good. So we're going to do a camera check, and then we're going to scale based on that. And then the last thing was just that normalized height as well. So get the world height and check that to automatically scale things like the wind speed. But we'll do those two in the next video. Okay, so in update, I'm going to add a scratch module. Now it wants to be an update because we want to check this every frame. And we're going to do a camera query. And if I type in camera, get camera properties CPU GPU. So that tells us that it works on both CPU and GPU. And what we're going to get is the camera position world. And I'm just going to write that out as a particle parameter. Like so. Okay, actually, let's do it within the module itself. That's what we did before. So we get the camera query, we get the camera position. We want to have the particles position. That is just a item of data we can grab. And then we also want to have a user parameter, max distance. So what's the maximum distance between these things? And then there is a normalize distance range function. And so the start position is going to be the camera. Just double check this. The end position is the position of the particle. And the maximum distance is the maximum distance. And that will give us a normalized distance to camera. So effectively what we're saying is at the camera, I want them scaled to nothing. As they're moving away from the camera, they're going to start scaling up until they reach a maximum distance, which we're going to input, and then they're going to be full size. So I'll do a new output, and this is going to be a float. And this is the normalized. Up to you if you want to spell normalized with an S or a Z. It should probably be Z. I picked an American company, and everything here says normalized with a Z, but I am obviously not American, and so I'm going to stick to my guns and write normalized with an S. Normalized distance to camera. Normalized range. There we are. And I'm also going to output the raw distance to camera as well. So very useful way of working. Whenever you're outputting a value that's, let's say, been normalized, you can also output the raw distance to camera. If it's not used, it doesn't matter. And the raw distance is just the difference between this position and this position. Now these are both particle parameters. And so we've got a module that outputs the thing we want, in this case normalized distance to camera, but we're also outputting the camera position and also the distance to camera as useful items of data that might be used in future. And I can give this a name. Scratch module, rename. For some reason F2 doesn't work for rename. You click and then wait, and that gives you access to rename. I don't know why it's not in the menu or not F2, but Niagara is new, interface changes all the time, maybe they'll fix it. Normalized distance to camera. Now I feel this is something we'd probably want to reuse, and so I'd make it into a module, and in fact I believe I have normalized distance to camera. Nope, NM, particle distance to camera. So that's saved out as an asset we could reuse. If I just open it, double check. In fact, I would have it open over here because I've been looking at it as a note. And you can see that's doing the exact same thing because I've just copied it. But yeah, normalized distance to camera now as a Scratch module. We're going to do this at the end. We can do it after we've solved our forces and velocity, or we can do it at the beginning. The important thing here is we're going to use this in our module. So just putting in a max distance here of say 100. Check what it's writing. It's writing out a normalized distance to camera. And I'm going to use that as a multiplier in my scale sprite size. So my particles are taking their initial size from here in the initialized particle. And then we're scaling them up by this animation curve. But then we also have a multiplier here, scale curve, where I can use that with my normalized distance to camera value. And what we'll find, particles within 100 units of the camera get scaled down. It's a bit of a subtle effect, but if I watch this long enough, I can see nothing ever comes in front of the camera. If I turn this on, occasionally we'll get a big particle kind of fly across the camera. If I make these a bit bigger, that might help. You can see really big particles when they're in front of you. They're really big. They look really terrible. But if I scale them by the normalized distance to camera, now anything within 100 units will scale down, or will start to scale down within that 100 units. Just put that up. Oops. And you can see if I use a very big value, it's only visible after sort of 1,000 units. Well, that's not very useful, but just to prove that it's working and check. Always a good idea to check your working, make sure that it is doing what you think it is. Otherwise you run into problems like I did with the collision module, which I thought was working, but actually was tricking me into looking that it was working. Okay, that's the quick normalized distance to camera Scratch module. Really nice little feature. Doesn't come at one of the existing modules, but quite an easy thing to put together. We're just getting the camera query data, checking it with a value, and creating a kind of like camera depth fade type effect, but here in Niagara rather than in Material. This effect can obviously be done in Materials as well, but by doing it in Niagara, it's a bit cheaper. Okay. What's the other thing we're going to do? Scratch module for normalized world height. Well, let's do that in the next video. Okay, so another dynamic check. In this case, we're going to do another Scratch module. And we're going to do a normalized height in world. So we're going to need to have the system position. So system position. We want engine owner position. There we go. So in this case, engine owner position is going to refer to the actor itself. So that is the actor. That's the owner of the component that we're editing. If this was attached as a component, it would obviously be the actor that it was attached to. Let me just check this. And then we want to have a input value of height. Let's do no, well, what do you want to call this? It's not just height. It's sort of the maximum height, I suppose. And we're going to do a normalized distance between them. Okay, fair enough. So we could use the normalized distance module, that kind of thing. We can also just build our own normalization. What do we want to do? Well, if I break the height, break the position, I'm only really interested in the Z value. And I want to know the current Z value as a percentage, not if, divide of the maximum height. So if my current particle's at 500 and my maximum height is 2000, I've got a 0.25, that's my normalized height. And then the last thing I need to do is just clamp it or saturate it so that I don't have any values now over 1. And we'll output this as our normalized world height. So it's a percentage, what is our current height as a percentage of our maximum height, but clamped between 0 and 1. And now at 0, there'll be nothing. At whatever the max height is, will be 1. And everything else will sort of scale in between as well. So let's rename this using the terrible renaming tool. There we go. Normalized world height. Now you might want to add an offset to this, depending on what your world height levels are. You don't really want the wind to scale to nothing at the ground. You maybe want it to scale to like 0.1, but we can obviously do that limit elsewhere as well. So get the normalized world height. Again, I'm doing this on update, assuming that my particle is going to be attached to my character and move around dynamically. If this was just placed in the world, I could get these values in spawn, and I'd only have to do the calculation once because, well, because it wouldn't be updating and it wouldn't be moving. Obviously, distance to camera needs to be per frame, but world height could be in spawn if it was a static thing. Okay, so I have my normalized world height based on this value. This is obviously not a very big value, but it works for the sort of debug scene that we're working in. And all we're going to do is multiply that into our wind force. And so this is where we want maybe more of a multiply many. Well, let's change this wind speed scale. One thing that, well, I was going to say you can do is copy and paste and then do nesting. Well, let's do that first. So if I just cut this value, create a multiply, float, paste that into there, and now I've got an access to another input. And this I could do as my normalized world height. That's probably fine. We won't use the multiply many in this case. Interesting. What's gone on there? Wind speed scale, multiply. Aha, I think I have worked out what's happened. No, that is still afloat. Wind force. Hey, I obviously know what's happened. The classic. This is based on a world height. This system here in the preview is at 0, so there is no world height. So we're just getting movement up. Let's have a look at the real world. And by real world, I mean digital world. Here at 0, the particles are just slowly floating up. They probably need some gravity, so they come down instead. It's picking up the lift from the wind force. We have a lift, aerodynamic drag, lift contribution there. That's why things are pushing upwards. We probably want a little bit of gravity to pull that down, really, because snow, despite being very light, does fall by gravity. And we'll do like 15 or 20, 50, 100, 150, 500. Oh, very static. So it's about 500 is my upwards direction force for that. Again, looking at it here makes no sense. Looking at it here, we can see now we're getting our falling. As we move this up in the world though, it's going to be picking up more and more wind and blowing across. And what I might do is say, add that limit, add that clamp. So here in my wind force, where I'm using the particles normalized world height, let's do a lerp. Use the world height, normalized height as an input. So by using normalized values, it's really easy to just kind of plug that into an alpha of a lerp, and then I can just choose my min and maxes, and we can just say, right, let's do like 0.2, 0.15, something like that. So at 0, we have a very low value. At 1, we have a high value. It's not exactly 0 to 1, which is what this was, but just gives us a little bit more of a value. Obviously, we could do things like curve it and scale it and all that kind of stuff. But, okay, awesome. Right, pretty much there with our snow system. I think that's doing everything that the template is doing. Apologies if you can hear the dog again. It's that time of the evening. Yeah, that seems to have covered everything. In the next video, we'll have a look at how we can make that dynamic input multiply many, which we've used in this case in the in the somewhere we use multiply many. I can't remember. I think we used it here in the previous example, and we used it in the spawn rate in this example. And we'll have a look at how to make our own dynamic interface multiply many in the next video after I've walked the dog. Okay, so last thing we want to do talking about the snow isn't actually anything to do with the snow. It's making this Niagara data interface, which I've called here multiply many, 4 inputs. Obviously you could make more if you think this isn't going to be enough, but the way we do this, if we go to our modules collection here, it's very simple. In effects, Niagara script, module script. So the way I would tend to make things is I would make a scratch module and then promote it or save it as an asset, but you can also just make a module script from scratch. But what we want here is a dynamic input script, and so class NDI. Let's bring this over, and it works very, very similar. So we have our input, we have map get, and we have an output. And so in this case, I'm going to remove this pin, remove pin here, and remove pin here. And my map get, I'm going to get float A, float B, float C, and float D, multiply. Now here, the multiply node does have extra input pins, so we can just do this, and then we can connect this to our output. How do we do this? We have to go to outputs, which are down here at the bottom, output parameters, add parameter, type float. There we go. For some reason, yeah, you can't drag and drop onto the node, but there we are. And this would be called the, if I rename it, this would be called the product. You get the product of multiplication. And there we are. We can make this exposed, and now it will be accessible in the input of any module. And so, for example, here I can type in NDI, NDI, and I'll get class NDI that I just made. But also it's the same as this multiply many. Cool. Let's just take that and unexpose it because I don't actually need it. Worth noting, all of the data interface, Niagara data interfaces that exist in the engine are in the engine content. And so if I go here and filter by effects, Niagara script. So add float. What do we do for add float? Well, we take 2 floats and we add them together. What about the align quaternions? Well, that's going to be a little more complicated. That's the dot product between these two inputs, inverted something, not sure, but there we are. So all these things exist already. Ceiling float, take a float and apply a seal command to it. Obviously, dynamic interfaces or dynamic inputs tend to be pretty simple, and it's the use of them, the combination of them with everything else that makes them more complicated or makes them more powerful. But as I say, we can make our own and we can do what we like with it. So the only one I've really done is that multiply many, and that's just a not really adding any extra functionality. It's just a sort of stylistic choice, as it were. So do check them out. They're all in here if you want to break them down and see what's what. Otherwise, just use what's built in for the engine. But I wanted to include at least one dynamic interface. And I think multiply many is quite a nice one to work with. Just makes things a little bit cleaner. So whenever you're multiplying, you can just do a multiply many. If you're multiplying lots of things together, rather than doing a nested multiply like we've got here, we could do a multiply many like we have in the spawn rate, and it's just a bit cleaner and a bit clearer to see what's happening, which is always a nice thing. So that is a Niagara data interface. Yeah, worth building up a library of them and using them if you so wish, but not an essential by any means. You can just nest a few other things together and that works just as well. So all right, okay, moving on from snow, we'll have a look at the mesh leaves, but we'll have a look at that in the next video. Okay, right, hello and welcome back to another video. So in this one, we're going to be having a look at the mesh leaves example from the worked example level, number 2 in our worked examples. And we'll just have a quick overview about what it is and what it's doing. And then in the next few videos, we'll break down and build it up step by step from scratch. So, well, I say from scratch, we're actually going to be starting with the blowing particles template. I always like to start with the template. It's up to you. It just gives you the basic forces and shapes and things like that. There's no reason not to use them. Although if you are just starting out and you're real kind of like at the beginning of your kind of Niagara career, maybe a good idea to actually kind of go in and build these up one by one as well. Entirely up to you. Hopefully we've covered these modules now in enough depth that if you do load in a template, you can kind of see, okay, there's a spawn rate, there's a shape location, there's some forces. That kind of makes sense. Okay, so the first thing we're going to be doing is swapping to a mesh renderer, and the mesh I'm using here is what I've called a double bent plane. If we open this up, you can see I've got my leaf material assigned to it, but if I just turn on wireframe, and a little tip, if you turn on wireframe and vertex colors at the same time, it hides the background, it hides the sphere, the sky sphere mesh, which is quite useful, so you can see your wireframe a lot clearer. Obviously we can turn the grid off as well, and we can see what we get here. So it's a 5x5 quaded plane with divisions. We need a division to create curvature. The more geometry you have, the smoother your curvature will be. So it depends on what you're doing, how close you are to it, how curved it is, how much geometry you need. But you are spawning quite a few of these, so bear in mind there is an additional cost to this. If we could cut an edge loop out of this, if we're spawning 50 meshes, that's 50 times however many verts you cut out and what have you. So it is an area where you might want to optimize, but current hardware tends to handle this kind of stuff pretty well, so it's unlikely to be making a big difference. So don't be wasteful, but also don't worry too much about the optimization, which is not very useful advice. But there we are, that's kind of how it is. So why have we got a double bent plane? Well, even if we think about something that's super duper flat, even just like a sheet of paper blowing in the wind, there's going to be curvature to it. It's never going to be perfectly flat. We saw in a previous example, we can use the align sprite to mesh orientation, and that will give us a 3D rotation on a sprite, but it will look flat. And there'll be periods where you can kind of like look it directly on and it will disappear. It doesn't look very good, it doesn't work for me. So by having a simple double bent plane, we cannot find a position around this in any orientation where it will be completely invisible. Sometimes it's a little bit shallow profile, that's fine. But it never goes away completely. So that's why we use a double bent plane, I would say. And this can be reused for different things, so it's not specific to the leaf. If it was specifically for the leaf and that was the only kind of mesh particle you were using, you could probably cut away some of these edges and just kind of describe your leaf much more accurately. But because we're using a masked material, we're not actually paying for the overdraw of this corners. Masked materials get culled out. If this was translucent material, we'd want to be much more kind of accurate with our vertex cutouts. With all of the material stuff, if you want to know more about it, do check out the materials course that I have put out, and we cover it in a lot more detail. But quick look at the material. So we have 3 texture maps. Now this is just a Megascans texture of some leaves on a floor, kind of a decal for that. And all I've done is taken this into Photoshop and chopped it up. And so we've got these 8 leaves, and then there's 1 repeat because there was only 8 in the thing. But yeah, obviously laid out 3x3 using the random value and a flipbook material node just to get a 3x3 grid, and that will be just a random value per particle. Each one will have an equal distribution. We could do a dynamic parameter and we could kind of weight it so we get more of one and fewer of the others, but something like this is probably fine just to be an equal distribution of randomness on these things. The masks texture, there are 3 masks I'm using, alpha channel. You can see here this is just the same one. I've painted a little bit out to give it a little bit of variation in that last one. We have our roughness, and then we also have our transmission mask. So this, when we're using a material such as this, where it's a 2-sided foliage, this is a subsurface material. So we have subsurface color, and then the opacity channel becomes what's called transmission. So it tells you how much light is being allowed through to the subsurface. Again, if you want to know more about that, check out my materials course, and we talk about that there. So normals, because we're doing with a 3D mesh, 2-sided profile, 2-sided set foliage, and it's set to 2-sided as well. So that's our mesh and our material. Nothing super complicated. We're not using particle color here. Note that there is no tinting of models. You could do that, that would be fine, but we're not using a translucent model here. We're using masked, so we can't fade this in and out. But that's fine. We're just going to scale them in and out of existence, and we'll see that when we build the material, build the Niagara system as well. Okay, that's the sort of mesh and material setup. Nothing else required in here. We're not using the sub UV in Niagara. Instead, we're doing it through the material. Doesn't really matter. I don't think there's any significant cost differences. I think potentially Niagara is slightly cheaper. Don't take my word for that. That is what I've kind of heard, and there's a sort of, but I'm not 100% sure. They're doing basically exactly the same thing. It's taking your UVs, doing some math to it to see a sub UV. Excuse me. Okay, so what's actually happening in the Niagara part of the material, or the Niagara part of the effect? Well, pretty obvious, basic things that we're doing as we're always doing: spawning in a location, spawning with a spawn rate, and then doing some forces. In this case, we're using the aerodynamic drag, which is designed for this align sprite to mesh orientation, and it's still doing something. What this is actually doing is updating the mesh orientation, and so we'll see that when we build this as well. We're getting a little bit of rotation from the mesh orientation from the aerodynamic drag, and then I've also got some extra kind of spin rotation rate modules here as well. So we're getting rotation around the leaf and around the leaf in 2 different axes, and we're getting some quite nice rotational motion because of that. Cool. All right. That is a quick overview. As I say, in the next module or next video, we will start from scratch from the template, and then we'll build up all of this effect as we just discussed. Okay, let me just stick that over there. So new Niagara system from selected emitters. We're doing the blowing particles, and I will call this class leaves. Check I've spent that correctly. I have, but with an extra thing. Class leaves. Scroll that out. There we go. Okay, so So I'll just take my emitter here and just replace what's in it with the new class leaves. And what we get by default is these little white discs that are doing spinning and rotating, and you can see they're already kind of like doing a lot of the work for us. Now, one thing this effect does, it does have that disappearing effect or disappearing visual artifact. Because it's a perfectly flat plane, sometimes you can see they kind of disappear out of existence, and I don't really like that. But if you can live with it, I mean, for small things it's maybe fine, but something the size of a leaf I would say would be too big and would look weird disappearing out of existence. So, or at least visually disappearing. So what it does do is this collision. So it's colliding with the ground, and you can see they're aligning with the ground nicely. Now this is something that this effect does. I don't think it's very easy to do with the leaves, unfortunately. It's a bit of a difficult problem when you think about it, because the leaf mesh has to know how to align with the floor, and when it does, it's not a flat surface anymore, so then you're going to get penetration. Also, leaves don't hit the floor and then slide along like these little planes are doing. They kind of hit and then they bounce and then they kind of do that kind of thing. So it's a interesting problem. It's something I'm going to try and have a look at solving with a sort of complex Niagara system and maybe include in the next course. So do check that out if I manage to solve it satisfactorily. But unfortunately, we're not going to have this effect in our mesh leaves because I don't think it's really possible, or at least not possibly in a simple way. We probably need to like calculate things and check stuff, and yeah, so beyond the scope of what we're doing. Where you've seen games where you think this is happening, it's actually just an elaborate fake. And so what you tend to have is leaves that are designed to live on the floor and roll around, and leaves that fall from the sky and look like they hit the floor, and then the two things kind of blend seamlessly, and your eye makes it look, or makes your brain think that things are falling down, hitting and bouncing and rolling around. But actually it's two completely independent systems, and it just appears that they work together. So notably, not Sekiro, the other, I've forgotten the name of the game. 1 second. Oh. Obviously, I mean, Ghost of Tsushima, dual underwater leaves. We look very closely. It's incredibly well done. The leaves on the floor that kind of pop up and bounce are a completely different system to the leaves that are falling down. It feels like they work together. It's a very convincing illusion, but actually way around. There's a lot going on here, but actually the leaves that are falling and the leaves on the floor are all completely different systems, possibly. As far as my view of it is, there's about 3 or 4 very clever things. So there's the leaf kick up from your feet, there's the trail that you leave behind where you've kicked leaves out of the way. There's leaves falling and there's leaves bouncing kind of ambiently off the ground and coming up again. But I think, in my understanding and my read of these, that they're not one system. It's not one clever, or leaves do lots of cool things system. It's 3 or 4 independent systems that just happen to work together. And if you follow a leaf as it gets kicked up and lands again, it kind of just disappears into the ground. It doesn't become a sort of a static object when it lies down on the ground. So quick aside, yeah, but hopefully that's quite interesting. It's a very well done effect, I think, and obviously your brain's really focusing on the combat and what's happening there, unless of course you're a VFX artist, in which case you're probably dying horribly in combat because you're too distracted by the cool leaves on the ground. But that's my kind of problem when I play games anyway. Okay, with that all aside, how are we going to build our system? Let's open this up, see what we get from the example. Here we go, class leaves, and here we are. So as I say, first thing I'm going to want to do is change the sprite renderer to a mesh renderer. We can see we've already got things like spawn rate, shape location, basic forces. That's all working really nicely. We will adjust this in a second. So the meshes we're going to use is the double vent plane, and that's already got the leaf mesh assigned, but we could obviously overlay leaf material assigned, but we could obviously override it here if we wished. Everything's gone a bit wonky. Why is that? Well, we're using a randomness within the material. Oh, I know, that's what's happening. Getting this flickering, things turning off, on and off. It's not the sub-UV, which is what I immediately thought it was. What's actually happening is the error that the system is telling us. The renderer here is using a masked or opaque blend mode, which writes to the depth buffer. This causes conflicts because the collision settings are set to depth buffer. So effectively what's happening here is the leaves are colliding with themselves, and it's really hard to resolve that because they exist in the depth, they're using the depth for collisions, and then they're kind of like, yeah, struggling with that. If we change this to distance fields, that should now resolve itself, which it looks like it has. So immediately with the collisions though, we can see a kind of error. They rotate nicely, they hit the ground, and then they become these kind of little sailboats, which doesn't really work. So this is the wrong orientation anyway. If I rotate my mesh, I can do a transform in here. And it will be, let's just try some things and see what works. Nope, still pretty sailboaty. Just trying to update the default rotation of the mesh to match the rotation that we're getting from the collision module. Looks like it's going to be a bit more complicated than I envisaged. Yeah, what's the align collision plane? I'm aligning. Align on Y. I think I want to align on Z based on what the model's made. Let's have a look. Don't intend to use this module because I don't think it looks very good because we get these sort of little sailboaty things. It should be able to rotate. So if I rotate these 90 degrees, they should be rotated and work better. But that doesn't appear to be what's happening. Just double check my rotations. Yeah, I was using 90, I was using whole numbers. Rotations here look like they're in the 0 to 1 normalized rotation. So 90 isn't 90 degrees, it's 90 times a full rotation. Unreal's unfortunately pretty inconsistent when it comes to rotations. Sometimes they are normalized 0 to 1, as in 1 being a full rotation. Sometimes they're in degrees, sometimes they're in radians. If you're working with a rotator node in materials, that expects your rotation angle as a radian, which is awkward and very easy to cause problems such as that, where I'm plugging in 90 and I'm not seeing any rotation here. Why not? Well, what's happening is I'm doing 90 times a full rotation, which isn't correct. So if you are doing rotations and it's not working, nothing's happening, just double check that the values you're using the right kind of space. It doesn't tell you in the tooltip anything like that. Yeah, so but as you can see, now we've got, it's slightly better. Maybe if this was something like onto a river where you could see the floating, and so they weren't kind of the penetration that you're getting wouldn't look bad, but here we can see we've got really bad clipping, and like the leaves as they hit the ground, they become these kind of weird boats that don't really look like leaves on the ground, in my opinion. That's not how they move. The wind, to get it any kind of horizontal movement, would have to be kind of big enough to push it. It would then flip up and come off the ground. Okay, we could just up the friction. If I just do a very high friction value, they might just kind of hit the ground and stop, but not even. Yeah. Yeah, so doesn't really work again, in my opinion. It might be we can do something custom. So we could write a scratch module, we could use the has collided. Once it was collided, it would stop any physics or any kind of further calculations, and you just get them statically hitting the ground. But the issue with that is that they start to then look fake. So let's have a quick look at, we can just do that actually. If I do a set new or existing parameters directly, and we'll do a particles velocity, and let's do a vector from Boolean, custom vector from Boolean. So the Boolean we're going to use is has collided. If it has collided, we'll do nothing, no velocity at all. If it hasn't collided, we will use particles velocity. So this is a sort of, again, trap type thing, I would say. So it moves around, as it hits the ground, the velocity should be set to 0. Obviously it's not being set to 0. If I try this before the solve forces and velocity, is that going to work? There's still something being applied here. But you can kind of see the issue that you sort of get there. There's this big snap as it hits the ground, big pop. Not sure why that's not setting that to 0. It should just be, maybe if I do it twice. That's weird. Let's try the, if I delete this, remove input, right click, and where are we? Remove. Not sure why there's not a delete, but if you want to get rid of something from here, you can remove the input. And let's try the transient physics force and set that to 0. Does that work? Yeah, I'm still getting movement. So about this bit of live debug, gone off topic, or not maybe off topic, but off script. So particle velocity, advection velocity physics. What's the solve forces velocity reading and writing? So I think it's using the physics solver. And so setting the particle velocity to 0 is only kind of killing part of it. It's still getting the physics based movement and things. So putting to 0 all that out as well. Transient physics force should be enough, but it's not. Particle velocity, set that to 0. Let's just set that to 0 all the time. And it's still being blown along by the aerodynamic force, wind force. What's this setting? Advection velocity, first frame. Let's try physics advection velocity. And advection velocity, set that to 0. Just trying to find the forces that are moving my particles. There we go, it's the advection velocity. So, do I need the physics force if I remove that input? Is that also going to be required? Looks like it is, yes. So, let's try and, whoops, not do that. That's not what I wanted to do. I'm going to add physics force. And we'll do we need particle velocity as well? Looks like no. Okay, so these are the two kind of physics forces that I used in the calculation in solve that are creating the movement. So rather than just scaling the particle's velocity to 0, we're actually going to scale the forces on the particle to 0 on has collided. So that is a vector from Boole. Same as before, has collided here. If it's true, that should be 0, no force at all. If it's false, we'll do the advection velocity. So while it's not collided, we're just carrying on passing the data through. If we copy this down, and this one is the physics force. Okay, what we should find is our particles spawn, they haven't collided, they move through the air, they hit the ground, and then they just freeze. I'm still getting some movement. But maybe you could do something like this. This is the sort of the path I'm going to try and look down to solve this problem. But unfortunately, when I've tried this before, if you just freeze them on collision, they tend to look static, and they almost look like kind of ninja stars that have been thrown into the ground. Because again, they've got that 3D element to the mesh. So you need to solve that problem at the same time. You see when you get this kind of thing where there's one spinning on the ground and clipping, and it all kind of just doesn't work. So hopefully I've demonstrated why that sort of doesn't work. And so we will not be using collisions in our example here. And because of that, we're also going to not use the align particles with collision plane. If you can get it to work, great. Please tell me how. It would be a very cool effect to spawn particles and then kind of come and hit the ground and collide nicely, and then occasionally kind of blow up and that kind of thing. And it's something I'm going to spend some time trying to solve for the next set of tutorials, but it might just be a bit of an unsolvable thing. At the point where you're doing all of that in Niagara, maybe you could just actually do a physics simulation and use in-net game physics instead, but by the by. Anyway, bit of a meandering class. Hopefully, though, that sort of shows a bit of the sort of thinking and way of working. The point being, we're not going to use collisions because I don't think you can make nice collisions happen with a mesh renderer and this kind of particle leaf and stuff. So, okay, in the next video, we'll add up the things that do work and we'll add sort of a few more rotations and things to this to make it a bit more lifelike. Okay, so which modules do we want and how are we actually going to build this effect? Well, firstly, a little bit of housekeeping. Scale sprite size is a module that came with our template. Well, we're not using sprites, so we don't want to use that. Instead, we want to use scale mesh. And we're going to do this using a float to drive the vector because we want uniform scaling. And we're going to use a curve to drive the float because we want animation. And I'm just going to use one of these templates. Maybe something like that. So on spawn, scale up pretty quick, and then over its lifetime, it's just going to scale away to nothing. Immediately we hit a bug. Our leaves have disappeared entirely. What's happening? Well, if we turn on the reads and writes, or have a look at the read and writes, particle initial scale is what's being read by this. But if we go to our initialized particle, our mesh scale mode is unset. So, a bit of a weird bug. If we don't have a size mesh scale in here, it assumes a size. So there's like a kind of a fallback. So our meshes now are all basically of size 1, which is fine, but we try and scale that value. What we find is we're scaling nothing and we get 0. So very common bug to hit. You turn on the mesh scales and then you go, where have all my particles gone? Because what you were seeing was a value that actually the Unreal Engine had made an assumption for you, which was fine, but yeah, not the right result. So if you do get this problem, it's a very simple fix. Just go to initialize particle and make sure we set a random value or any value in the mesh scale mode. We would have come and done that anyway. Of course, we want to have some randomness to our size. And so if we'd done that first, we wouldn't have come across that bug. But if it does happen, just be aware that when we're multiplying our mesh scale size here in update, same with color as well, it needs that initial value to be set, and it doesn't always set if it's set to unset, but it doesn't mean it's not showing you something. Yeah, software development is hard, easy to create bugs, but luckily we know them and we can work around them. So mesh size, I'm just going to do, let's say, half the size that's imported and 1.5 times the size that's imported, just a little bit of variation. Now our mesh scale size is going to work, and so our particles are going to appear, scale in, and then disappear by scaling out. So you need to have some way of bringing in and taking away particles from the world, fading or scaling. And for sprites, well, sorry, for translucent objects, fading tends to work quite well. But for mesh objects here with an opaque renderer, we're going to use scaling. Cool. We have a randomness to our initial mesh orientation. That's fine. There's definitely some very high spins happening here. So I might just want to go in and adjust some of our offsets in aerodynamic rotation. So the way this is working is it's doing some various calculations, and then it has this offset value for basically, as it's doing a rotation, it's rotating around a sort of pivot point, and so that's what this pivot offset min, max and length is doing. And if that value is too small, well, you're able to get these very fast spins. Now if you're making something that does spin fast, like confetti or maybe sort of smaller petals that are falling, kind of like that, that's not going to look too bad. But for these quite big objects, the rotation is just way too high based on the size of the object. It's very, I mean, the force required to get that to spin like that would be really, really high. But we can fix it. Let me just check what I used before. So my pivot offset minimum just reduced that value down. And I think I left the maximum and the, oh no, I reduced the maximum as well. And then the minimum length I've left the same, but there you go. So you can change these values, play with them until you get something that works. But you want your pivot offset to be a little bit different from the default. So I'll bring that right down. Let's do minus 0.05. 0.05. So it looks like it's the value in Z that's really affecting this. So we definitely do want some spin. Sometimes we get spin, but not as high as the default values. Oh, what have I done wrong here? That should be a positive, negative. And there we are. So you can kind of see now there, there's a sort of like pendulum motion sometimes. So the bit that it's rotating around is this pivot, and so the pivot offset is changing. And so as long as it's far enough away from the leaf, you get the kind of rotational movement that you want. But if it's too close, you get that very, very high spin. So as I say, up to you to play with these values until you get something that works. Okay, just sticking with rotation. So we have the aerodynamic rotation. If I turn the sprite renderer back on, you can see it's definitely aligning with the mesh. They're sort of at crosses to each other because of the orientation that they've imported at. But the aerodynamic drag, this is affecting the physics forces, the solve forces and velocity is affecting the mesh orientation. And then the align sprite to mesh orientation module is making sure that our particle sprites are aligned to our mesh sprites, mesh objects, mesh rendering. And so we don't need this. We don't need the sprite renderer or the align sprite to mesh orientation. We'll get a warning saying we need to use this, but actually it's not true. Because it's setting the mesh orientation and we're using a mesh, that's fine. So we can just click dismiss and that will go away. Or you can just leave this on doing nothing. That's a bit wasteful. Cool. If we want a bit more rotation to this though, we covered the mesh rotation modules. In update, you can have a mesh rotation, either a mesh rotation force, or I think I'm going to use an update mesh rotation. So the mesh rotation force is probably what's already being driven by the aerodynamic drag. So instead, we're going to add a rotation rate update mesh orientation on that. And so that will be independent of the physicsy bit that we're already calculating. And what we're going to do is just have a rotation vector. This is in mesh space, so let me just open my mesh and have a look. So in this case, I want my primary fastest spin to be along the x-axis. Could maybe have modeled this slightly better so that the leaf was a bit more aligned, but it depends on the texture, I suppose. But we can see our primary spin is going to be in the x-axis, and then we'll do a little bit of secondary spin, probably in z. And so we're going to get spinning on our plane kind of like that way, which is the primary spin, and then we'll get a little bit of rotation sort of that way as well. Not sure how well that's coming through in the video, but something like that. Okay, so update mesh orientation, rotation rate, rotating around the x-axis of the mesh coordinate system, and I'm going to do a random value And let's do like -5 to 5, something quite big, just to see that we've got the right axis. And you can see as they're moving around, they're kind of spinning around their main primary axis, which is what I want, but not as fast. So I'll just do like -2 to 2, something like that. And then I like copy and paste this module and do a rotation around. In this case, maybe we'll do world up. That might be interesting. So we're now doing the world Z axis. So, and then we're sort of always spinning around that way. And we'll do like a little bit less. And so just trying to nest a few rotation updates together. So we've got the physicsy one from the aerodynamic drag, and then we've got rotation around the primary axis, and actually rotation around the world up axis. So we're always getting a little bit of spin that way as well. And you can add more, and you can kind of fiddle with these until you get something that kind of works quite nicely. But I think there's a nice amount of variation to that now. Looks pretty natural, I think. Only problem we do have is this colliding and dealing with the ground, but we've discussed that. It's unfortunate, but it's not a simple fix, if it isn't even fixable. But there we are. Okay, let me just double check my template. One more thing we could do, talking about the wind force. So before we covered this, again, we have the MPC values and global values. So if we do a multiply many, that's not going to work because this is a vector and I haven't made a multiply many for vector. Let's do vector by float. The vector is going to be driven by a linear color. That linear color is the wind direction, and the float is the multiply many. And so we can do our wind speed or wind intensity. We can do the, did I have another one? Oh, that was in the previous example. Let's just look back to the previous snow. Where's my snow system gone? Up here. Obviously we're dealing with wind. If the level might have snow and leaves in it, it makes sense for them to be the same. So here we did wind speed and it was just a random value. So I didn't need the multiply many after all. That's fine. Well, we can just leave that there and just use multiply by 1. Let's do something like, I don't know, between 30 and 50 as a starting point. Maybe that's a bit low. But the same idea as we covered before. So using the global parameters for things that make sense to be global, such as wind speed. That works quite nicely. And the last thing we can do, if we want a bit more movement, a bit more motion, just added a curl noise as well. So putting that up here in with the forces. And I'll do the same thing. So I'll pan it along the wind direction. And this is a vector from linear color, color being wind direction. Obviously, if we stored our wind direction as a vector, that would be more useful for Niagara, but quite often the wind direction is also used in your materials, and then it makes sense for it to be a linear color because materials don't understand vectors directly, they understand them as linear colors. And we can obviously adjust the values here as well, so more or less noise, quite a low frequency curl noise. When working with noises and forces and things, sometimes quite nice just to turn everything else off and just isolate it. Now unfortunately there's no kind of quick isolate value like there is for individual emitters, but it only takes a few clicks to turn on and off what's happening. So that's our curl noise. Maybe let's make this a little bit stronger. So kind of creating this kind of blowing around. And as you sort of bring these back in, wind force requires aerodynamic drag to work. Maybe up my curl noise. Another good tip, just to double check that it's doing something, putting a very high value, and you can see here that it definitely is doing something. If I put that to 0, it's very sedate and not moving very fast. If I put in maybe not quite a high as value as that, but something like 5,000, just to check. Again, Niagara doesn't always do what you think it's doing. Sometimes it's multiplying by an initial value rather than the latest value and that kind of thing. So it's sometimes good to just double check. If you're trying to subtly tweak a value, don't subtly tweak a value because maybe it's not doing anything anyway. Chuck in a huge value, see what it does, make sure it's actually working the way you think it's working. And then obviously if it isn't, you can debug and kind of work out why not. But something like that, doing a bit of curl noise, bit of gravity, and then the rotation as well. And end up with something like this. It works quite nicely. Okay, cool. That's everything I think for the blowing leaves example. In the next module or next video, we'll have a look at building up a muzzle flash. Okay, right. So in this next example, we're going to have a look at this muzzle flash effect, and we're just going to go through the emitter as is here. As an overview, there is a lot of different component parts to this, but none of them are doing anything particularly complicated. It's just the combination of lots of bits, nicely made, working together, and so we'll go through this. Firstly, to note, it is set to be an infinite loop. That's just obviously for preview purposes. This would ideally be just set to once. This is more of a kind of like a single burst weapon. Looks like quite a large weapon. It's got a few sparks coming out of it, things like that. So maybe a large rifle or what have you. If you were making a submachine gun, you'd make that as a looping effect, and you'd kind of turn it on and off when required, rather than kind of like spawning a burst per bullet. Very expensive to do that. Don't want to do that. We just want a repeating effect that's on, repeating effect that's off, or in this case, this would be a one-time fire kind of single shot weapon. But I want to see it repeating just for preview sake, so that's why it's set to infinite. So just be aware that's not the correct setting for the way of doing this. It's just a sort of a preview thing, so you can see in the world it keeps repeating and things. Okay, so first thing to note, I have split this into two types of thing. I have additive elements, so all of my sort of flaming, glowing, sparking bits, and then I have smoke as separate commented out sections, which is nice to sort of break it down. And then we'll go through sort of bit by bit, and it's just a case of combination of combining different things together. So here we have a sprite sheet. So I've called this Fire Escapes. This is from a fire pack that I made for the marketplace a while back. They're just flamey shapes. They're not designed to be animated. They're not designed to be kind of combined together over time. You just pick one, and where's my background? I can't see very well. Preview scene settings. Oops, that's fine. Show environment. You should live over there. There we go. It's just designed to be a picker shape. Looks like a flamey thing. If you look at muzzle flashes, they are incredibly quick. You want a single frame of this at most. That kind of flame bark that you get of the hot gas releasing and being ignited is very, very quick. It looks very cool when you slow it down in slow motion. You have the very, very high frame rate cameras, and you can see the evolution of it moving and burning out and stuff. But actually in real life, when you look at it with the naked eye, you don't have big flames that last for hours or seconds, or frames even. It just wants to be a single snap, and tends to feel better that way as well. When you're playing gameplay, you want your weapon to be quite responsive, and also the flames not to fill the screen and distract you or kind of make it hard to play, unless obviously that's intentionally what you're going for, and etc. So yeah, 9-frame flip, or 9-frame sprite sheet. In this case, I've done it 3x3 sub UV in the Niagara system, and just using a random frame in the sub UV emitter. Opening up the material for this, let's have a look. Let's go to details, materials. I'm not going to go too deep into material. As I say, it's not that complicated. But if you want to know more about materials, check out my materials course. So using our texture, we're using a dynamic parameter to create some contrast. Because this is stored as a black and white texture, and then we're using a gradient curve to actually colorize it, we can consistently use the same gradient curve for all elements to create some nice color consistency, which is nice to do. But if we also allows us to do things like contrast before colorizing, and so things like flames, they don't fade away, they burn out. And so the dynamic parameter here, you can see as that gets higher and higher contrast values, it's really kind of like removing the mid grays and the low grays and just leaving those white highlights. And so where we can kind of animate this using a dynamic parameter, we can create some really nice realistic kind of burning out of flames. It's technically called alpha erosion. It's very common for any kind of combustible flamey thing to do this. You can do it via power with contrast. You can do it via subtraction as well, and that works the same kind of way of removing the low values. Up to you how you want to do that, but rather than just doing a straight opacity fade, we'll do a contrast fade. We do have opacity in here as well. Okay, that's basically it for our muzzle flash fire. Simple burst effect. We're doing a small probability, so you don't always get a particle. Sometimes, effectively, what happens is the burning out is quicker than the frame rate of the camera, and so it just doesn't spawn enough gas or whatever. So we don't want it to be always on, but most of the time we're going to get a sprite. Random size. With something like this, you'd really want to randomize as much as possible, except potentially the lifetime. If we random this, if we do 0.05 and even something like 0.15, that's going to work out like 3 frames roughly at sort of a decent frame rate, and that's already too fast. Lifetimes below 0.05 seconds sometimes can live less time than the frame rate, at which point you just don't see the sprite, I believe. So maybe 0.02, 0.05. It can be hard to see this because it's also got the spawn probability in there. But now it should sometimes just not show me the sprite. That might not be true in the latest. Yeah, no, I think it's always giving me at least 1 frame. But 1 frame is what we want. So I'm just going to put that back to direct set and just use a really low value and make sure that we always get a single frame, and then use the probability to mean that we don't always even get a frame. So most of the time it's giving us a particle, and sometimes not. But as I say, other things you want to randomize, so color, just used, well, not color, sorry, but actually we could. Let's do a random range in color. The alpha is controlling the emissive. So if I go back into here, this is an additive material. It's a glowing material, and so the alpha channel is working as a multiplier in our emissive channel, which works quite nicely. So I can use that to create brighter particles, and so something between sort of 25 and 100 maybe. Now we'll get a bit more variation in color, based on a bit more variation in glow and brightness. Random size, random rotation, random X and Y, flipping, all of these things are good. Random sprite, and here we are using a random contrast. So this one's not animated, it doesn't live long enough for that. Instead I'm just using a random amount, and we can go a bit harder with this maybe, get a bit more variation. You can use values below 1, it'll just kind of flatten out a bit more, so you'll get a bit more fire there. But again, just plugging in the values that work with the textures that you have. And then I am scaling the color to 0 as well. You're not really going to see this doing anything over the lifetime. Maybe that's unnecessary, because this sprite lives so short. Well, no, actually I think it does work. It does add a little bit. And that's it. That's it for the muzzle flash fire. Say very simple emitter, just simply spawning a single frame with a little bit of probability, randomizing as much as possible. And I'm using the texture to do most of the variation as well. So just a 3x3. I'm also using a material cutout on this as well. So all of these sprites have the material cutout enabled, which kind of gives you a little bit of optimization cutting around the sprites there. So okay, next video we'll have a look at the rest of the additive sections of this effect. Okay, so second thing I've done or added here is a spark burst. Exactly the same idea. Only difference here is we're not doing a 3x3 texture. Instead, it's just a single texture. Oh, little error there. That cutout's wrong. That cutout should be set to the spark burst. There we go. But apart from that, it's exactly the same. So it's spawning a particle. Maybe we will have a different probability. Let's maybe like that a bit less likely, just to create a bit more variation. Add that color variation that we did before, and we're not using the color really. If you have better color vision than me, you might want to choose different colors and you make it do a random tint, but my color vision isn't very good, so I tend to just rely on a color gradient where I can color pick things. And we can see now, if I just turn these two on together, that should work. Most of the time it's just a little flame. Sometimes there's a spark as well. I'm just creating some variation between these two. The fireball's got a bit more to it. So looking at the sprite, this is a animated texture just from a fire simulation. So this is obviously designed to be animated, but using the same parent material. So in this case, all the flamey effects are using the same parent material, which makes things nice and consistent and easy to work with. Using the gradient curve to keep things clean and consistent, so everything's going to be colorized the same. But in terms of spawning, now we have, again, just sometimes spawn a particle, sometimes don't. Maybe we want to adjust the probability of that again. Up to you, depending on what you're trying to make. We've got a little bit of velocity from a cone. So spawn our particle, fire it forwards. It's got enough lifetime to get a little bit of animation to it. And now we're using sub UV animation, just set to linear. The texture here is obviously not designed to be a random start frame. It's got a very clear progression from start to end. Apart from that, all the same, we're doing a color curve, and this time our dynamic material parameter, we're still using the contrast. That's the only one we've built into this material, and now we're animating it over its lifetime. And we might even go a bit higher on that, looking at the values we looked at before. As always with animation, we might want to adjust our tangents as well. It's one of those things where it's so quick, you kind of have to look at it for a long time to kind of see the variations and differences that you're getting. Sometimes can help just look at it in the world as opposed to in the preview. We're getting a little burst of flame, and again, not always happening, just kind of a low probability, but it's still just one sprite. We don't want to overdo it with these things, depending on the effect and the reference we're using, etc, etc, etc. So apart from that though, all the same, scaling up the size a little bit to kind of show the gas expanding and kind of like breaking up, but as it's also getting bigger, it's also getting contrasted using the dynamic thing here. And we could also put all of these curves on the curve editor. So haven't really used the curve editor that much. I don't tend to. I just do my work in the curves here. But you can add multiple things, and if you multiple select them, you can access them and edit them at the same time. You can also pin them, and then that will now not go away if I select other ones. So it's quite a nice way of working if you really want to get into sort of editing your animation curves and editing multiple things at once. But not something I personally do, but I know people who do. So okay, Last one in our little additive section here is just some sparks. Using again a sprite sheet for slight variation type things, one with a heavy lead, one with a bit more of a kind of small group, and then the sort of different thicknesses and different weights. Even tiny little things like this, it's worth a small texture. The texture itself is going to be, see how big I made it, 512 by 256, pretty tiny in the terms of modern game hardware. Obviously it could be smaller again. We can scale this down, maybe load bias it by 1, it's even smaller if that is causing problems. It's 21 kilobytes, I'm pretty sure we can afford that to have some texture to our embers. But the same principle, contrast, particle color, and so on. Now this is a different material because I'm not using the depth buffer fade. They're small enough that you probably don't need it, and it allows us to do the velocity right, output depth and velocity, which helps with the TAA smearing you get on very small particles. So that's why this is a separate material. No. In terms of the system though, or the emitter I should say, not much difference. Again, we have a spawn count. This time we've got a larger value. Maybe we want to add some randomness in there. Where possible, add randomness. Even just something like that. Maybe between 8 and 15 sparks. When they do fire, sometimes there's more, sometimes there's less. It's going to create that. It's not so much of a kind of, I don't know, an acknowledgeable difference. It's more of like a feeling. And so it feels a bit airy-fairy, but computers so good at doing repetition, and the real world is so bad at doing repetition. Everything is unique and dynamic, and so there's no reason not to do a random spawn rate, random spawn count, and then random values and all this kind of stuff. And it just helps to create that kind of, yeah, that feeling that there is something dynamic and random and things happening in here rather than it being repetitive. So yeah, different values in spawn, different values in lifetime, different values in color. Let's do that as well. Oops, not unset, sorry, let's be random. 111 for the color, and I had like 500 before, so let's do 250 and 1000. And you say you wouldn't be wrong, just you can't really see any difference there, but there is a little bit of difference, and so over time, as you play this a lot, you'll see it will just feel slightly better. I think anyway. Random texture, covered this. Cone velocity, covered this. Hopefully you can see these different parts. The system itself, or the emitter itself, isn't doing a huge amount of complicated things. The combination of the 4 emitters together into the system creates sort of some nice variation and nice yeah, dynamic elements. And so because they've all got slightly different probabilities of spawning and this kind of thing, you tend to get a lot of repetition, a lot of uniqueness to it. It's not just doing the same thing every time, which is cool. All right, that is the 4 additive elements. Single sprite, some sparks. Not sure I super love the sparks. I might try and contrast them about a little bit, make them a bit more subtle. Maybe that's a bit too much. Kind of sit here and fiddle too much, but yeah, some single burst frames, a slightly longer animation frame or animation emitter that has a little bit of lifetime and animation to it, and then some individual small sparks as well. So that makes our additive parts. In the next video, we'll have a look at the smoke and those 3 systems or 3 emitters that we get here. Okay, so moving on to the smoke elements of the system. First one here, I've called it lit smoke. It is appearing to be lit smoke. It's not a lit thing though, it's just using a smoke texture in my fire shader. So rather than calculating lights and doing sort of 6-point lighting or all of the sort of complex things, this thing is going to be over in 1 frame. It's the same idea as the sparks and the fire burst you get above, but now it's a sort of lit appearance or lit smoke that appears to be lit because it's illuminated and glowing the same color as the fire. Same settings as before though. Apart from that, there is a spawn probability. In this case, I've got a spawn count of 2. That's probably something I should randomize. Let's do between 1 and 2. As always, if you can randomize it, do. Why not? Spawn probability, 0.9 is probably fine. We can do this. Lifetime, let's do random here as well. 0.02, 0.05 might make a tiny bit of difference. Random color, always using white, but randomizing between, let's say, 5 and 25. And so now sometimes it's brighter and sometimes it's dimmer. Random size done, random rotation, random flipping. All of this is good. In this case though, it is only spawning a single sprite for a single frame. This texture is designed to loop. You can see from the last frame and this first frame, there is a consistency to this, but that also doesn't mean we can't just use a random frame from it. The particle doesn't live long enough to need animation, and so just by spawning a random frame, we get sort of a sprite sheet, we get some randomness to this. So sometimes it's going to be this kind of smoke, all of this kind of thing. And what works quite nicely is with our longer living smoke, we're using the same texture. And so there's a consistency to that. And so the shapes you're getting in your smoke and the shapes you're getting in your burst of lit smoke are obviously the same, which helps them to read together and sort of cohesively, coherently. Yeah, they hope to read together. Cool. Again, random contrast, not a problem. And then just scaling out the color as well. So nothing particularly difficult or unusual about this. The idea that we're using a kind of smoke texture, but with it illuminated in just a single burst, one frame of it. And if I put this on with the next one as well, and turn these on together. Obviously it doesn't always work, but the two kind of things read together quite nicely once they work. Maybe needs the smoke to not fade in the same way. So this is fading in, it needs to be a bit quicker. Maybe we'll make our sprite start a bit smaller and scale up. I don't want to spend too long kind of fiddling. Not seeing my spark here anymore. What's happened here? For some reason my lit smoke has disappeared. I'm not getting any particles, 0. Yeah, okay. That seemed like a bit of a update bug. Not sure. It doesn't like having a random range int in my spawn burst. I've definitely used that up here. Interesting. Or have I not? Yes, I have. That's working. Not quite sure why that's not working. As a flash lit smoke, should be using a random range int. That is killing my particles. Well, let's do some live debugging, see if we can work it out. And if not, then we will give up. Turn the spawn probability off. No, not seeing any particles. Spawn burst particles. Is my lifetime too low? Let's try the lifetime. Oh, it's definitely something to do with the spawn. don't know. Let's try a fresh module. Spawn burst instantaneous. This shouldn't make any difference. I'm definitely spawning a smoke. If I do a random range int and I randomize between 1 and 1, I get nothing. Really interesting. Okay. Yeah, I don't know why that's not working. It's the same setup as here, and this works. So that's unusual. What is it reading? Engine delta time, these are all the same. Loop count, looped age. Loop count limit's not turned on. That is very weird. Infinite. Yeah, okay. Well, in which case we won't randomize the number of sprites we have here. Not entirely sure why that's not working. If I multiply my int by a random float. Does that work? That seems to work. Okay, that is very strange. So just using a random range int between 1 and 2 seems to kill all my particles, and I don't know why. It's the exact same setup as we have on the other emitter doing the same thing. Is there anything different in here? That's in local space, that's in world space. We'll get onto that in a second, but that shouldn't make any difference. I'll turn that off. That's not going to make any difference, is it? Or is it? Okay. So nice bit of debugging. There is no reason that local space should make any difference to the random range in spawn count. But it does seem to. So the fact that this is a local space emitter and the other one is a world space emitter is the only difference I can see. And if I change that option, it definitely changes the results as well. So if I just double check this, if I turn on muzzle flash sparks, I am using a random range in my burst. If I turn on local space, I'm still seeing sparks, so that doesn't make any sense. Okay, well, we found a really weird bug. Not quite sure what's happening here. Maybe there's some other settings that I'm missing. Who knows? But the fact that this is local space appears to be killing the spawning of the particles entirely because I'm using a random value here. I don't understand, I'll be honest. Okay, so the random each loop, but that's enabled here as well, isn't it? Yes. We want that to be enabled. So in all fairness, recalculate random each loop shouldn't really matter because this shouldn't be a looping system. But because it's a looping system in our preview, we do want this to be enabled. Otherwise, it would just pick a value on spawn. So you'd create your muzzle flash, and it would just be like, oh, I've picked between 1 or 2, and I'm going to be 1 for the rest of time. So we do want this to be enabled, but it also seems to be the thing that breaks things, or at least it unbreaks things if it's off. But the local space fixing and breaking things is absolutely mind-boggling how that makes a difference. But there did appear to be a bit of a workaround though. Ah, okay. Now is it working? No. So if I local space this, it kills it. So weird. Okay. But there did appear to be a bit of a workaround. Rather than using a random range int, we'll do a multiply int and we'll multiply by a random range, which again should be exactly the same and compile correctly. Like that shouldn't be anything, I'm just multiplying by 1. But it now appears to work again. So I'll be honest, never seen that before. Not sure why it's doing it. Doesn't make any sense, but there we go. It does appear to be a bug that's doing that. Now obviously we'll put our lifetime back to be very, very quick. And so what we get is this initial burst of lit smoke. That's the result we want. Quick frame of it being lit up. Obviously it's not really lit. We could try and animate the first frame of this and have a very bright color for the first part of this, but it just doesn't work. The values and the animation speeds and stuff you want, well, it might work. It's very tricky to do, I think. Just much easier. Have two emitters. There is an overhead to this. Emitters do have quite a big overhead compared to the number of particles that they're doing and things. So there's definitely a bit of performance that you're spending having this one shot burst of lit flame. But I think it works quite nicely. Cool. Okay, let's talk a little bit more about smoke, and we'll do that in the next video. Okay, so one thing that I'm seeing a little bit of here that you might notice as well, we're using particle cutouts. Now the particle cutout values, it's set to the right material, but the hard edges, you are occasionally seeing some hard edges on this, and you can see them there happening there. And so there's a warning here about cutouts will not be sized dynamically with UV scale variant. And I believe that is referring to the UV flipping mode here. If I turn that off, let's just isolate just this one. Well, we're still getting some hard edges. We can make some adjustments to this. So there's 4 verts or 8 verts. You can pick which channel. In this case, maybe color brightness would work better. There's no alpha channel to this. That seems to have worked a bit better. And you can also have the alpha threshold as well. So the default alpha threshold is quite high. 0.1, you definitely get the hard edges on that. 0.01, that's going to maybe work a little bit better. But other option, if that's not working, is you can also make a separate texture, which is much clearer, and kind of the alpha value on an alpha texture, where we have an alpha, tends to be much more kind of solid values. In fact, we're using this as our alpha, and we're using solid values for our color, and it can cause a little bit of problem. So sometimes you might make one with a little bit of padding around it. So the alpha texture you're using for the cutout is slightly bigger than the texture you're using for the sort of rendering, but it is an extra texture that you would need for that point, or at least an extra channel packed into a texture. But that seems to have worked. So changing to, or using back the default of 8 and using color brightness instead of color channel red shouldn't make much difference really. But if you are seeing those hard edges, do go in and adjust your cutouts. Maybe I can turn my UV flipping back on. Yeah, so the UV flipping, unfortunately, the UV has been flipped and the texture is now backwards, but the cutout is not backwards, and so the cutout and the things don't line up anymore. So if you are using particle cutouts, you maybe need to turn off the UV flipping, if you're seeing those hard edges at least. Okay, so what's this smoke doing? Well, basically this smoke and this fireball are exactly the same. It is a particle spawning with some randomness that appears to work this time. There is a shape and some velocity. There is some animation to the size. This is a looping flipbook. So it's a linear animation with a random start frame. If this was off, it would look very repetitive every time, because now it's always using that first frame. Doesn't look too bad, but you can start to see the same swirls happening at the same point. The different lifetime, so the fact that there was a random lifetime to this helps break that up a little bit. If everything lived the same time, and also you can see really it's quite artificial, but luckily there is just a random value in here, or a random checkbox, and now we're dealing with random values to our sprite, or to our animation, scale and color, and then again using the dynamic parameter to add some fade outs to the contrast. So material for this is smoke flipbook. Very simple, same as idea as the fire material. Obviously this time we're not colorizing it. If we wanted, we could reuse the same material and just colorize it black to white, but it seems a little wasteful. So I would make a smoke material and a fire material. In fact, actually, take that back, that wouldn't work. This is obviously translucent, and the fire material is additive. So yeah, separate materials that are very, very similar, but that's fine. Cool. That's our little smoke burst. Smoke linger. So I would do this as a separate thing. So only difference really here is that the particle's living a little bit longer. So maybe let's try and fix the cutout on this as well. Let's go back to 8. Turn off flipping. There we go. My contrast's starting too low. If you're seeing little hard edges, I think maybe there's not very well made texture. There's maybe some hard edges. If you put this to 0, you can see we're getting these lines around the outside. It's not very good. But if our contrast's set to at least 1, we don't see them. So let's maybe go in there and make the same here. Just make sure that our contrast is set to decent values. Okay. So smoke linger, what's the difference here? Well, the smoke linger wants to last a little bit longer, basically. So I would spawn fewer particles with a longer lifespan, and that gives us a little bit of smoke that sort of lingers around. We obviously don't want to keep all the smoke around for performance reasons, but a little bit occasionally that lasts a bit longer can be quite nice. There is also a difference between local space and world space. So the short-lived smoke is attached to where the gun fires and happens and moves, gives you sort of coherence and consistency with the end of the gun. And then the lingering stuff, obviously that has to be in world space, and so the sort of stuff that stays around happens there. And if I turn these both on, like so, it's a bit difficult to see in the world here, but if I have this selected, I can move it back and forth, and you can see one of the smokes is kind of attached and one of them is just sort of left in the world. So that's the idea between that anyway. Most things here are going to want to be in local space. All of the very fast living things can be local space. If they're not, then they might get detached. Okay, that should be in local space. And so it's a difficult thing because you've got a gun that's moving quite quickly, and when you fire, technically everything should be in world space, but then you get gaps, and because of the way that particles spawn in and fade and this kind of thing, so it can cause problems there as well. So experiment between local and world. You probably want some in local, some in world, and combine the two together, but be aware that it's quite a tricky sort of path to weave, because you want some things to be attached and be consistent with the gun, and some things to be in world space. And so at some point you have to sort of make a decision about what works best for the particular part of the effect that you're working on. Okay, that's about it. I think that's everything we're going to cover with this. Just as a quick recap, broken down into additive and sort of smoky. I mean, technically this is additive, so maybe that should be at the top, but it made more sense to be smoke. So we've got fiery, maybe we'll call this fiery elements rather than, or combustion. Smoke's actually part of combustion, but anyway, the fiery elements at the top here, little burst of flame, single sprite, very quick, just picking from 1 of 9 frames. A spark burst, probably I'd want to make a 4x4 for this to create some more variation. In this case it's just a single texture that always happens. That's fine, but it could be better, so we'd go in and probably make a 4x4 with some variation, or 3x3, however much variation to texture, etc. we want to do. More variation you have, the more your texture is now smaller, so there is obviously a trade-off with that. We have our animated flipbook, so a non-looping animated flipbook of a fireball. It just has a little bit of lifetime, not loads. And then finally, obviously, the spark. So again, picking 1 from 4 to create our fiery elements. And then 3 smoky elements. 1 that's a very quick fake illuminate. 1 that is a fast lifetime or short lifetime, fast moving, attached local space, and one that is a slightly slower, longer world space, and that gives us our sort of smoky elements to it. As I've set up here, the more you can randomize this, the better. You can see just from me going through this now, I added a bit more randomness, randomizing color, randomizing size, randomizing scale, randomizing lifetime, randomizing spawn, all of it. You want to randomize everything you can, especially something like this that's going to happen a lot and again within gameplay. So yeah, cool. All right, as I say, I won't go through and build these all up. There's a lot of duplicate or a lot of duplication between these, a lot of consistent things, and also it's not loads of really complicated things happening. These are all modules that we've covered multiple times and hopefully make sense and are usable. So cool. One thing I will say as a final thing, these emitters are just emitters in this system. So if we were working on a large project and we had lots and lots of guns, I would not expect these to be independent for each system to system. I would go in and I would make an asset and I would call it, I don't know, muzzle flash smoke. And then for all three of these smokes, or maybe you'd have smoke burst and smoke loop, and you'd make some parent emitters and then inherit those. Same for your muzzle flashes. You want to have kind of like a library of starting points and then add them in, make some changes that make sense for the one you're working on. It just means that later on, if you need to make changes to the parent, they'll propagate to all of the children, which will make things a lot simpler. If you've got 15 different guns and 15 different completely independent muzzle flash effects, and then you need to make a change to, I don't know, the speed of the smoke, you have to make that change 15 times. Whereas if it's 15 muzzle flashes that are all inheriting from one smoke, you can make that change once and it will follow through. So I haven't done it here because I'm only making one, and so I don't really need to, but I would definitely advise, if you are making things for large scales and be using them a lot, make assets, and let's just make one. Let's see, and let's call this Niagara emitter muzzle flash smoke burst template, and we'll call it just muzzle flash smoke template. And there we are. So now I can set my kind of like defaults in here, and every time I want to add a smoke, I can just go, okay, muzzle flash smoke, add this template, and work from there. And this is a separate asset that exists on disk. You can see it here. And this is a emitter or an emitter. So we can't bring it into world directly. We have to create a system for it. So we can right click and create a system for it, or we can just add it to the existing systems, etc. Okay, that is it for my muzzle flash. One thing we could add is a light. We could add a little particle lights, that kind of thing, depending if we've got the performance to do that, but we've covered particle lights, so we won't cover it again here now. Looking at my next example, that's going to be the campfire, and we'll go over that in the next video. Okay, so next example we're going to be looking at is the campfire. A lot of very similar things to this and the muzzle flash, similar elements, and we're just going to go through step by step, discuss what each emitter is doing, break it down, and we'll see the end result as we get here. So again, I've broken this down into sections. So the first section is the additive elements, or sort of fiery elements. There's no smoke on this fire at the moment. Obviously you could add some smoke if you wanted, but all the same principles are going to apply to the smoke systems, emitters that you might want to put in. So starting with the mesh flames. So you might recognize this mesh from my materials course if you've done that, but this is custom made for this effect. And so taking the logs as sort of arranged here in the world, exporting them as geometry, and then you can make custom geometry that kind of goes up and around. It's probably a bit too dense, to be honest, but by having the geometry around the logs, you're able to kind of get really precise placement of that. It does have that issue of edging, And so as you go around, you can see if you align the camera with it as a flat plane, this is what I was kind of talking about with the mesh leaves earlier. And the way we fix that is just with a Fresnel. And so the fire flames here actually fade out as you go around them. So here's our model. As I say, probably a little bit higher on the old wireframe. I could probably cut a few of these edge loops out, but it's unlikely to be spawning. Well, we're only ever going to be spawning one of these meshes, and so having a few extra edge loops isn't going to cause too much problem compared to, say, the leaves, where we might be spawning, I don't know, 50 leaves or something. So it's not as critical to be optimal with, but also it is a bit wasteful. I'm not going to go too much into the material. Again, this is from my materials course, but effectively we're just playing a flipbook on the mesh. So find the flipbook here. So an 8x8 looping, and we're doing the logic for this here. So we're using random values from particle random, and then random contrast, random intensity, all of this stuff that we could randomize in Niagara using dynamic parameters, or we can randomize here using random particle random, etc. And we're using a little bit of world position offset to create some movement as well. So we're not doing things like scaling the particle over time. Instead, we are using the material properties to do this. So obviously the last course was all about materials. This course is all about Niagara. When you start combining the two together, you get sort of the next level of complexity and things. So most of this material, or most of this emitter, all the power and complexity is coming from the material in here instead. If we look at the system, or we look at the emitter, all it's doing is spawning some particles over time. We have here a, where's my thing? Yes, infinite loop, and I'm using that random range loop trick. And so sometimes it's a 4-second loop, sometimes it's a 7-second loop, and then throughout the emitter, different things will have been designed to work in different parts of that loop, as we discussed before. One thing I am doing here, which I think works quite nicely, I have a system-wide parameter. So in this case, I've created a system-wide parameter called fire intensity, and I'm just animating it. So in the system update, it's scaling up, scaling down, and what we're going to do is we can use this for lots and lots of things. And so we can use it with our spawn rate, we can use it with our kind of emissive intensity, and so the whole fire as a sort of group, rather than randomizing or animating each individual thing independently and kind of like hoping that it works, we're animating one single value here at the system level, passing it down to all of the emitter children, and then when we have more sprites, then they are also brighter and they might also be bigger, and so we get this kind of consistency between our kind of elements. So I think that works quite nicely. The reason we're setting it here first is because if we don't, we should get an error, although apparently not. Okay. What did I change it to be? System attributes, system fire intensity. Where is the setting that I want? That is okay. So usually if you're doing this, maybe it's because it's been set somewhere. Sometimes you get the error saying that it's been set, being accessed before it's been set. And that's what this is trying to fix, just to make sure that we've created the particles parameter. You can also edit the parameter settings so that it is has a fallback default. But I tend to just kind of add this in instead. But actually it's not required. So if I turn this off, it's not doing anything. Which, it's interesting why I've done that in the first place then. Okay, well, there we go. Doing a system-wide parameter that can be then copied elsewhere. And so if we have a look here in the little arrows, so it's not used instantly in the mesh flames, but here the initialized particle, scale color, shape location, scale color, all of these things are referring back to that single value. So as the fire intensity goes up, we will get more particles, they will be bigger and brighter, the vortex will be stronger, etc. And so it's quite a nice sort of way of working. Okay, that's our mesh flames. Again, not loads of Niagara going on here. They're just spawning, and we're using the material to do most of the work. And I refer you back to my materials course if you want to know more about that. Small flames. Well, the flames here are very rigid. They are very much in a very specific place, not very dynamic, and also fade away to nothing on certain angles. And so to cover that, we have some small flames that are spawning with a spawn rate. They are having a random size, but also scaled by this fire intensity. So this is where the animation in the system level is kind of making these bigger and smaller, but it's kind of working en masse. So they're all bigger or they're all smaller at once, but still with some randomness within that as well. We could do random color. We should probably have random lifetime. Let's go around here and say maybe 3 to 5, something like that. Okay. What else are we doing? A little bit of vertical velocity. We have a cylinder spawn volume on the ground. So just using well, it's actually a disk because it's a 0 height cylinder. Could have used a disk, but it's basically the same. And then, yeah, scaling up our particles, scaling color. Again, with the scale color, I've used the system intensity value here. And we're doing a random start frame looping fire. So same fire material as before. In this case, using a looping fire texture. So again, scaling the curve, using a bit of contrast, and so on. That's small flames. Large flames, same idea, different texture. So different kind of shapes you get. The bigger your flames are, the more kind of turbulence and variation you get within that. And so the small flames have a bit more kind of verticality and just straight upwards, whereas the large flames have this kind of a bit more of the licks and what have you. So just using a different texture, but exactly the same idea. And in this case, we have the system parameter also controlling the radius of our spawn volume. So when the fire intensity value is low, it's a small sort of central little fire like here, and then as the intensity goes up, that scales up. And so the spawn volume changes, the size changes, the color changes, the intensity changes, all driven by that single value, which works quite nicely. Okay, last one in our kind of additive flame unit elements is the embers. Same idea again. So we're just spawning a variation in particles. So our spawn rate is controlled or is also modified by our fire intensity. When our intensity is high, we spawn more particles. That makes sense. But additionally, I've got 3 spawn bursts in here as well. So random values spawning at random time. And this is where that random loop comes in. So our random loop length combines with our 3 spawns to mean that they're not always happening. If any of these times are over the random value. It doesn't look like they actually are. It's maybe not the best use of this. So our random length is between 4 and 7 seconds. Let's change that to be a little bit bigger and make this spawn burst happen at, let's say, 3.5. So this spawn burst here sometimes won't happen at all because the loop range here is too short. And so sometimes a loop might only contain the first 2 bursts. So again, combining that random loop range with our set timings to create some more intricacies and variations to this. Cool. Apart from that, things are the same. Picking a random frame, scaling the spawn volume, adding velocity. Probably this velocity maybe we'd want to be, let's do multiply float. Also multiplied by the system value. So let's do system intensity, fire intensity. So now when the fire intensity is high, the particles are slightly faster. And you can see that kind of effect kind of kicking in subtly, which is quite nice. So sometimes our embers faster, sometimes slower, etc. And same with things like vortex force. So So we covered all the forces. Here the vortex force, when its intensity is high, it's a bit more swirly. We could do the same with the curl noise. Maybe make our noise strength. Let's make this a multiply float, and let's do a random range float. Somewhere between 35 and 75 multiplied by the fire intensity. And you can see how you can just kind of go in almost category by category, almost parameter by parameter, and say, let's add some randomness, let's add some control, and let's combine these things together. And once they're all combined together, you'll get a nice nice result, nice animated, realistic result. Cool. Using a bit of upwards force here in gravity. Well, it's not really gravity if it's an upwards value, but as we discussed with linear acceleration, all three of the linear acceleration nodes kind of do the same thing, so it doesn't make a big difference that we're using that there. Okay, so that's it for our sort of glowing additive values. We've got a very specific mesh. We've got our small flames to help break up that repetition. We've got our large flames in the center. Maybe these are a bit small. Maybe make these a bit bigger. They're getting a little lost in the actual campfire itself. As I say, I'm not going to sit here and tweak it too much. I think I've gone too far now. And now our flames are maybe a bit too big. Maybe it's okay. But that's the idea. So we've got specific things, random things, little backup elements. And that's a very common breakdown with effects as well. You have your sort of primary visual things, your secondary visual things, and then your little detailed visual things. And that combination, or sort of the three things working together, helps trick the eye into thinking there's lots more variety and complexity happening there than you might see. Okay. That's everything I think I want to say about this part of the campfire. In the next video, we'll talk about the two additional things we have here, which is some heat haze and a particle light. Okay, so firstly, let's start with the light. We talked about lights. Can't see anything here in the preview, there's no world. Just having a single emitter controlling the lights. We could add lights to fire, that would work. We can have multiple renderers on the same emitter, it's not a problem. Trouble is, our fire flames are all down here at the bottom. We don't really want that, we want our light to be up here. And so I've just made a system that doesn't have any other renderer. If I just turn the sprite renderer on, you can see them. And so these are our lights, so they're up here, but they don't look like anything that would be in the flame, and so therefore it doesn't really work. So I would have, rather than adding lights to an existing emitter, I would make a custom emitter that's kind of lights only. And all it's doing is it's taking its light values, as we discussed when we did the light breakdown. So radius, color coming here from the initialized particle. Sub-UV animation, that's almost certainly doing nothing because we're not using sub-UV because of our sprite. That's a copy-paste error. But you can see the movement of the particles and then the animation of the light radius. Things like this are helping to create this sort of soft flickering glow. Firelight is very soft because it's such a large radius or large object that's casting the light. Every part is casting light, it's not a single point source. And it has this sort of variation to it as well. So making sure that we're animating all the values within that makes sense. In fact, we should possibly take this value and animate it. So let's do a multiply float, 75. And we'll multiply by the fire intensity. Well, let's multiply by the fire intensity. But I've also put another intensity value in here because I believe this is going to give us too much variation, and so you can see our radius going massive and small and things. So if I just take my fire intensity and let's not multiply it, actually that's a lie, let's lerp our fire intensity with 1. So what does this do? Well, if I put a value of 1 in here, we're getting the full fire intensity value, but because it's a multiplier, I don't want to scale it to 0. That would scale everything to 0. So instead, I'm lerping between my fire intensity and 1. If I set that to 0, now I'm getting full fire intensity, and you can see here the amount of glow is variation is very, very high. I'm going to reduce that down. If I put a value of 1 in here, that's now using this value, and it's completely static. But something like 0.8 or 0.7, we're getting a little bit of variation with our fire intensity. So where are we? So this curve, taking this curve and effectively flattening it down. So I've taken this value of 2 and taken it by 0.8 down here. And so we're just scaling that down. So using the animated value here, that allows us to very quickly change this and adjust it, and that affects everything in the system. But only taking a little part of it, because the value we're animating here doesn't want huge amounts of variation, just wants a little bit of variation. Hopefully that makes sense. As with all lights, I've disabled inverse squared fall off, and yeah, other settings are basically the same as we've already covered. So spawning a different amount based on the fire intensity, different size, different scale, etc. As always, particle lights don't cast shadows. Not sure that makes that much difference for this. The shadows, you would get shadows around here, of course you would, but a shadow casting light would be more expensive. Probably the first sort of approach I would try and see whether it was doable would be to have the particle lights as such, and then also have one shadow casting light in the center, possibly animated via Blueprint, and so using a light component and doing that and moving it, either via Blueprint or nowadays using the component renderer. And so you have one shadow casting light that's expensive, a few particle lights which are cheap, and then you see if your performance can handle that, because any kind of particle lighting and multiple dynamic lights is always going to be a little bit expensive. So, but again, the idea of the illusion of VFX, one particle light with shadows and lots of animated lights. One particle light with shadows will be too hard, and you wouldn't get the nice soft flickering kind of soft light you get from fire. But lots of particle lights without shadows don't give you the shadows that you get from fire as well, so you sort of combine the few together. So maybe that would work best. Okay, last thing on our system here is distortion. Now this is just particles using a heat haze material. Depending on the amount of heat haze that you want. Again, not going to go too deep into this, but talk about refraction. We're using a refraction input. Make sure that your refraction settings are set in the material properties, the material sort of defaults. That's a new thing. If you're on older versions of Unreal, it will be automatic. If you're on the latest, you now need to enable refraction, and it's just set to none by default. And we're using some normal map kind of vectors and just creating some variation with this. If your refraction's too high, you can scale it down. Here I'm using the dynamic parameters to do so, but if we scale it down too low, it disappears. Now this is an engine cutoff hard limit. I made a YouTube video about it recently, so go and check that out. You can make some engine changes and go in and actually make a couple of script changes to the engine distortion shader to sort of fix that clipping. But again, I won't go into too much detail here. You can check that out on YouTube. As for the particle, it's not doing very much. The material uses refraction and sort of panner speed, and we can randomize our panner speed and animate our refraction value here in Niagara. But apart from that, they're just particles that are spawning and moving upwards, and so following the same kind of shape and everything else as the fire has. Okay. I think that works quite well. We've got, say, a consistent, coherent flame that matches the logs. We've got dynamic fire sprites, or two different types of dynamic fire sprites. We've got a global parameter that is controlling everything at once, and it controls the size, the scale, the brightness, the emissive, the everything, and so that gives us a nice cohesive look. But because it's animated over time, it gives us some variation. The loop variation is random, and so sometimes it's a little loop, sometimes it's a long loop. That combines with the spawn burst and the animated fire intensity to kind of create more repetition as well. If this was just a 5-second loop and you watched it for 15-25 seconds, you start seeing that repeat. And so that randomness breaks that up as well. And then finally, we've got some heat haze and some particle lighting as well to kind of even push this even further. So yeah, combining all together. The component parts I don't think are that complex, but by combining sort of six emitters together, we get a nice result where each one is doing slightly different things, but the end result reads cohesively. So using the same flipbooks, using the same colors, that kind of thing helps to sort of bring this together. Cool. Final example we're going to go through is this mesh dissolve, but we'll do that in the next lesson. Okay, so the last example that we're going to go through here in this Introduction to Niagara course is this one, mesh dissolve. Now, if you've been paying close attention and you've watched all the videos up till now, hopefully there might be an inkling of how we might want to do this, but obviously we're just going to break it down for you now as well. So we have two emitters in this system. One is the mesh itself that is going to dissolve, and one is the embers that are going to come off it as it dissolves. Let's just turn the bit off and see this a bit better. So starting with the mesh. So you're looking at the mesh renderer. It's custom mesh, SM parchment. It has a material assigned to it, and it has some vertex colors. So looking at the vertex colors, there is some noise in the different channels, and we're going to use that to help break up our effect, which is a good start. And then looking at the material itself, different things happening here. So I have the base shader here in the center. At the texture, it is just a kind of imported, I think this is Megascans again, texture here. And I've done the text as a separate layer. Obviously, if you don't want my company name across it, you can remove this and reuse it in your own work. So that's why I didn't bake it in here, where you could change that to whatever you like. But it's just a simple material here. I'm using the opacity channel. So I have an opacity mask, which we'll be accessing through Niagara as well. That's my roughness. And then I have a height as well. So there is a bit of world position offset to this, creating some 3D height. So the mesh itself, mesh itself is flat, and then there's a bit of height pushed into that. Okay, that's the main material. We also have a fiery edge, and so this is, let's just preview it here. This is our fiery edge. So this flamey texture just multiplied by itself, panning along. Again, if you want to know more about materials, do go and check out my materials course. But nothing too complicated to this, just two flames. Where this does become a bit more interesting, we are blending these two things together based on an edge mask. Where's that coming from? So we're using the vertex colors, taking the red channel and the blue channel here, inverting one and combine them together. You can't see anything here because the model needs the vertex colors, but actually if we select the material properties and put the right model in, if I could spell it, parchment, we should then be able to see the vertex colors correctly. There we go. So taking the red channel, so that's giving me a gradient from this corner out to that corner. So we want to kind of control our burn effectively by saying, well, this is going to be in this corner, this is going to be in this corner, this is the dark areas that's going to burn first, this is the light areas that's going to burn least, and then we add some noise. So we've got a vertex color noise in here as well, and we've just got a scale control for that, so we can include how much noise we want. 0 is going to be no noise, 1 is obviously maximum noise, somewhere in the middle seems to work quite nicely. We add these together. Didn't find that was enough, so I added some texture noise as well. And so we've got the same fiery textures before, this time not animated, but we can control how much of that noise is there, or again, not there. And then I'm using two parameters here, mask and edge. So if we just duplicate them here as a preview, mask into mask, edge into edge. And so what we're going to do, as the mask value scales up, make sure we're previewing a node that makes sense. The mask value lerps here between 0 and 2, and then we're subtracting that value. So to start with, a mask value of 0, we will be subtracting 2, and so our opacity disappears entirely. As our mask goes up to 1, we see the full mask, and then same with the edge here as well. So as this scales up, we then control our emissive. So we're blending between the two things. We're animating values that go up, and then as the value goes up, it burns away, and then the same masks come along and add that emissive edge, and that's what we're getting here. So hopefully that makes sense. So if our mask value, let's set our edge to 0. Now it's all edge, and you can see we've got flames everywhere. If our mask is 0, we've got paper everywhere. The mask is 0.5. Now we've kind of blended between the paper and the flames. And if our edge is 0.45, something like that, maybe even 0.5, depends how much of an edge you want. But our edge value now is blending between the alpha. So we've got one value controlling the alpha, one value controlling where it's burnt and where it's flames. And as long as those values are very close, we're going to get a very thin edge, which kind of gives us the illusion of burning and things coming through. Which is pretty cool. So just going to put those two back to where they were. That's the idea. Obviously we're not controlling that through a material, but instead we're controlling that through the dynamic parameter in Niagara. Okay. This logic, we are going to then take that, and if we go back to our mesh dissolve system, what we're doing is using the dynamic material parameter. I'm just animating the burn value, or rather, in fact, I'm animating it here at the system level because I want it to be shared. So I'm using the burn mask value, starting at 0, moving up to 1 at 5 seconds. And then in here, I'm using the burn mask and just taking a little bit away from it as well. So give myself a little bit more control. So the mask is driven by the burn mask, and the edge is the burn mask minus a little bit. There we go, that's what I've done, if that makes sense. So if we just take the burn mask in both values, you get a very, very thin edge, but I want my edge to start thick and then get thinner over time. And so I'm doing that by subtracting first nothing and then subtracting more and more. So the burn kind of changes dynamically as well. So using a single value here to animate both properties, and then kind of creating an offset, but not using a static offset, but using an animated offset, if that makes sense. So burn mask, subtract here. If I change this to be just a static value, you can see the edge is consistent all the way. If I subtract a bigger value, it's going to be wider, and that's now really far too wide. But if I want to animate that value, I'll just do a curve, and then I'm going to subtract. Oops. Hope this isn't causing issues with the recordings, but I'm getting little stutters. So if I start by using a bigger value, and then over time it scales down to a smaller value. Well, yeah, we can adjust these values, but that's the idea. So starting with a thicker edge and then animating it to be a slightly thinner edge, something like that. In terms of this emitter, that's kind of all it's doing. It's spawning a mesh and it's animating those values. That animation is being driven here and also here. So using a system-wide parameter and also a local parameter. And then the clever thing happens in the embers. And so we'll break that down and we'll have a look at that in the next video. Okay, so last little example video of the course. Yeah, apologies if there has been some stutters and things throughout the video. Not sure the video encoder likes the Unreal particle stuff that we're doing at the same time, but hopefully it's still followable, and if not, let me know and I'll try and re-record these, which would be a pain, but there we are. That's such is life. So what's happening with our embers? Well, the logic that controls what's visible in our parchment is completely repeatable in our system, and that's exactly what we're doing. So the logic here is driven by the the vertex colors of the mesh and the texture of the alpha channel, and so what we're going to do is just take those two items of data and just access them again here in our system here. So if I turn off my kill modules, what we're doing is a static mesh sample, and you can see here we are just sampling the parchment mesh. I'm getting the particle position and outputting it. I'm getting the vertex color as well. So I'm applying the position and I'm getting the vertex color, and then I can say, right, well, using that vertex color and then using my burn mask, I can kill particles off, and that will kill the particles that are effectively in the area that hasn't been burnt yet. And you can see that happening. And I can also sample my texture. So in this case, I'm sampling the alpha channel of my, I'm sampling the blue channel of my alpha mask, and I'm doing a rejection sampling. So any particles that are spawning outside of the paper automatically get killed. And then finally, the last kill is doing a kill on what's kind of already burned. And so using the same logic, the burn mask, the sampled vertex color, these are the areas that have already burnt, these are the areas that haven't. So I'm not sampling the noise and the texture noise, we're only using the vertex colors here. You could do that as well. I mean, you can completely take whatever logic you have here in your material and recreate it exactly in Niagara. But that's effectively what we're doing, is we're saying, right, I want to take an animation, I've got a gradient from black to white, I've got a gradient and some noise to create some variation. I'm going to animate the value kind of through that gradient, and then I'm going to do the exact same thing with Niagara, and then in the material we're using that as an opacity channel, and then in Niagara we're using that with a kill module, and so just spawning particles everywhere and killing them off. Hopefully that makes sense. So there's 3 rejections here, or 3 kills. One is the opacity of the texture around the outside. One is the particles that haven't been burnt yet, or for the particles spawning here on the paper that hasn't been burnt yet. And one is the particles that are spawning in the areas that have already been burned. And so by having a slight offset between the two, slight variation, and again, if I put these on my curves, I can do this, float by curve 2 and float by curve 1. You can see the 2 values, slightly different gradients, and so we'll start with more particles and then we'll scale down to basically having none. So where that crosses, they'll stop spawning any particles. So just adjusting these 2 curves together by having them on the curve editor here. And that's it. That's the setup. Taking all the material logic, replicating it in Niagara, and then just using it to do a slightly different thing, in which case kill module as opposed to, or kill particles as opposed to material opacity, which I think is quite a nice example of everything we've been talking about over the last few hours, combining data, or getting data, using data to drive data, and what it's stored in vertex colors and spawning kill module, that's fine. If it's stored in the texture and it's using to adjust color, that's obviously fine. At the end of the day, it's all just data, and Niagara is just managing that and moving it around and building up these kind of systems such as we have here. Cool. All right, that has been a bit of a marathon. Hopefully it has been interesting, and there has been some interesting things to talk about. There's been a lot. Niagara is a very powerful piece of software. Hopefully the module breakdowns weren't too dry, and there's a lot of information there, and the worked examples give you some idea of how we can use these things. Not everything needs to be incredibly complicated and have lots and lots of variety and lots of complex modules. We can do a lot by combining lots of simple modules such as the muzzle flash and so on. Yeah, as always, if you have comments or questions, please don't hesitate to get in touch. Always happy to answer questions or take some ideas and use them in future tutorials, whether that's a big course or whether it's just a YouTube thing. So yeah, please do reach out if you are struggling. Do check out the Real-Time VFX forum and Discord if you want to learn more about Niagara and you want to share work, get help, get feedback, all of those things. They're great communities, great places. I'll be there answering questions all the time as well, so you can reach me directly there as well. But as always, thank you for doing the course. I look forward to seeing your work. Please do tag me in it, tweet at me, that kind of thing, if you want to share what you've been doing. It's great to see more people getting into real-time VFX. It's a great profession. It's really interesting. There is lots and lots of work in it, which is great at the moment with all the recent developments that have been happening and redundancies and things. So it's a great place to be getting into at the moment. And do write reviews, share the work. Yeah, all definitely helps. And do check out the advanced stuff coming as well. So I'm going to do another Niagara course that's going to be the more advanced things, and then I think a third course that's going to be Grid 2D focused as well, and then maybe some fluids in future, but that's going to be a long-term thing if that ever comes. So yeah, thank you very much. I hope you've enjoyed, and I will see you all in the next one.